Hello everyone and welcome back to CodeByTushu. I hope you are having an amazing day and making consistent progress in your coding journey. So today's problem is LeetCode 3739. Count subarray with majority element second. So if you already solved LeetCode 3737, you might think we can simply use the same brute force and solution here. So unfortunately that approach is so fair to slow and but containers is in this hard version are much large, so we need completely different strange. So today's problem, first of all, starting, so let's start again. So first of all, problem understanding. Problem understanding, like we are given array, an integer array nums and an integer target, and we have to count all subarray where target to majority element. So, and the hard part is that must count all such subarray efficiently, and brute force solution would check every possible subarray and which task like omega n square, and we will excited the time limits. So, and next is key observation. Instead of storing the original number, so we only care whether each element is the target. So, and replace every element with if condition, use the double equal to target like this, and like therefore the target is the majority if the only if the transformed subarray sum is positive. The completely change the problem, and now we only need to count subarray those transformed sum the greater than 0. So, and approach step by step, like transform every target into +1 and every other value into 1. So next is maintain a running prefix balance and store all previously seen prefix balance inside a binary index. So next is for every new prefix, count how many prefix previews are similar. Each of them forms a valid subarray. And next step, insert the current prefix into the binary indexed tree and continue. So let's again, guys, Java code. So first of all starting Java code starting these value, and first line is I think we create a Fenwick tree the support as a prefix frequency update and query update. So next line is private as a Fenwick tree array, and next line is public as a containers initialization the tree, and next is the Fenwick trees are generally elements using one based indexing, so we allocate one extra position. And next is update the position update function, like adds a value at the particular index. So, and move update upward through the Fenwick tree and update the current node, so like this, and jump to the next responsible node, and is the same core idea behind the Fenwick trees, like, and Next is the query function, like return the prefix frequency from, and use the store the frequency, then move the toward the root and add the current contribution and move to the parents node and return the total prefix frequency. So next line is main solution by LeetCode and public function solution by LeetCode. Next line is store the size of array, and next is the prefix balance can be becomes negative inside of storing negative inside index, and we shift every balance into the positive range. So we create throw space for all possible balance. And next is our transform prefix sum is 0, but we shift by n plus 1. So next is insert the empty prefix before processing any elements and store the final answer. And next is use the for loop again, process every element one by one, and condition use the if the current element equal the target, increase the balance. So and next is target contributes, so like this. And any non-target contributes, and continue valid prefix, like we count how many prefix previous balance and strictly smaller than the current one. So the and next is return the total number of valid subarray, and complete his code, guys, and save the code, and now submit the code. So we will wait guys, and low. So complete right code is right, and complete strict 74 days, guys. And so our thing like same thought process, and click the cross button and case 1 and case 2 and case 3. So in this value, like time complexity, each Fenwick tree operation task like omega log n, and we process every element once, overall omega n log n, and space complexity omega n, but a value overall omega n. So this was a fantastic hard level big question, because the real challenge was not implementation the Fenwick tree, it was discovering the mathematical transformation and that convert the majority condition into the positive prefix sum problems. Once the observation clicks the restart, and the solution becomes the more manageable. If you enjoyed this video and learned something you new, don't forget to like this video, comment your approach, and subscribe to CodeByTushu channel, and share the video coding friends and non-coding friends, guys. And thank you so much, guys.